student, we have discussed mole concept in the previous video. Today we will learn to calculate the percentage composition of different elements in a particular compound. For example, here we have taken an element and compound Na2CSO4. In this compound, we will calculate the percentage of different elements. How can we calculate the mass percentage of any element in any compound? We will take its mass, okay, mass of that particular element divided by molecular mass of compound. इस compound के molecular mass से divide कर देंगे into 100. In this way we will calculate the mass percentage of one element. Come on the next. For next, the formula remains same, but the mass we will keep of sulfur in place of sodium. And the last, for oxygen, we will keep the mass of oxygen. Let's do a numerical to understand this concept. Here, first we will calculate the molar mass of Na2CO3. Okay, when we will keep the molar mass of Na and sulfur 32 plus 3 into 16, that is for oxygen, then it will come 142. It means the molecular mass is 142. Now we will calculate the mass percentage of different elements one by one. Let's take sodium first. Na, sodium. What is the mass of sodium here? Here we have Na2. It means it will be 2 into Na. Okay, because 2 atoms are present. Divided by molecular mass, that is 142 into 100. And what will it become? It become 2 into 23 by 142 into 100. On dividing, we will get the value 32.4%. This is the percentage of sodium. Now come on the next. The next is sulfur. What is the mass of sulfur here? 32. Only one atom is present. And it will be divided by molecular mass of the compound. That is 142. And when we multiply it by 100, we will get the percentage of sulfur. That will be 22.6%. Now the last element, that is oxygen. Oxygen is 4 atoms. 4 into 16 upon 142 into 100. What will be then? Come, it is equal to 45.05%. One more method is there. If we take the percentage of sodium, that is 32.4 plus percentage of sulfur, that is 22.6, and the sum of both of these is subtracted from 100 because 3 elements are there, and then we will again get the same value. Okay, if we have 3 elements, then we need to calculate for 2, and then on adding them and subtracting from 100, we can calculate the percentage of third one. In this way, we can calculate the percentage composition of any compound. You will do this numerical, you will calculate the different mass percentage of different element present in calcium sulfate, CaSO4. Okay students, you will do it. Now we will come on the next concept, that is molecular formula and empirical formula. What is empirical formula and molecular formula, and what is their relation? Empirical formula is the simplest formula, whole number ratio, okay, of various atoms. For example, if we have C2H4, that is the molecular formula of ethene, and if we want to know its molecular empirical formula, then we can divide it by 2. It means it becomes CH2, the number of atoms we will see, and the simplest whole number ratio is CH2. For example, for benzene C6H6, it will be CH. We can divide it by 6, both of them, and the simplest is CH. Hence, the empirical formula of benzene is CH. Okay, students. Now, if we want to calculate it, then if we know the number that is represented by N, we can calculate the molecular formula. If we have empirical formula and value of N, then we can calculate the molecular formula. For example, if any compound, that is CH2O, I am taking this example CH2O, and value of N is equal to 6. Okay, students, then what will be its molecular formula? We will multiply each number of atom with 6. Then what will it become? It becomes C6. 2 को 6 से multiply करेंगे 12, and it will be 6. C6H12O6, that is glucose. This way we can calculate the value of the formula, molecular formula, with the help of empirical formula. We should know the value of N. And how can we calculate the value of N? By dividing the molecular mass upon empirical mass. Okay, students, molecular mass, what is the molecular mass? That is C6H6. We calculate 6 into 12 plus 6 into 1. 72 plus 6, it will be 80. Okay, students, and if we want to calculate for CH, then what it will become? It become CH. For CH, it become 12 plus 1. It become 13. Now dividing, we can calculate the value of N. Okay, students, 78. It will be 78. And what is the value of N? N becomes 78 upon 13. It will become 6. So, if we know the molecular mass and empirical mass, we can calculate the value of N. The next topic is how can we calculate the empirical formula and molecular formula if percentage composition is given. It is very important numerical. First of all, we will suppose that we have 100 gram of that, and this percentage become in gram. It means carbon is 64.80 gram. If the numerical is that, we have a compound in which carbon is 64%, hydrogen 13.62, and oxygen by 21.58 by weight. What is its molecular empirical formula? Molecular formula is given. Okay, molecular mass is given, and we need to calculate molecular formula. So first we will calculate the empirical formula, then molecular formula. For that, first we will take all elements in gram by assuming that we have 100 gram of compound. The second step is we will divide them with molar mass. Carbon 12, hence we will divide it by 12. Hydrogen has 1, we will divide by 1, and oxygen has 16, we will divide by 16. Now what will we do? Now we will see which value is lowest among them. We have 3 values, and which value is lowest? Which value is lowest, students? Students, here 1.349 is the lowest. We will divide every number with this number. It means 5.4 by 1.349, 13.02 by 1.349, and the last one also. And what will we get? We will get 4, 10 and 1. Okay, students, C4H10O, C4H10O. This is the empirical formula. Empirical formula we will get, and then we will calculate empirical weight. How we can calculate the empirical weight? 12 into 4 plus 1 into 10 plus 16. It will be 74. And what is the mass given? 74.14, which is approximately same, and we will get the value n is equal to 1. What will be the molecular formula? Molecular formula is equal to n into empirical formula, and it is also 1. And in this way we calculate molecular formula. That will remain C4H10O. The last. Now we will discuss the last topic for today, that is limiting reagent. What is limiting reagent? Students, if we have lots of milk, lots of tea leaves, but we have small amount of sugar, so the sugar is the limiting reagent, and we cannot make the sweet tea, lots sweet tea with the help of this ingredient. अगर एक भी ingredient कम होगा तो जो भी चीज़ हम बना रहे होंगे उस कम इंग्रेडिएंट की वजह से बाकी चीज़ों का यूज़ ज़्यादा होने पर भी कमी हो पाएगा. This reagent is called limiting reagent. The reagent which get consumed first or limit the amount of product formed is known as limiting reagent. Let's discuss this with the help of a numerical. We have a reaction, that is A plus B2 gives AB2. Here A is one atom, B2 is a molecule, and we will get a molecule AB2. This is an addition reaction, and we will do the numerical. This is B2. Now take one by one. The first one is identify the limiting reagent among followings. The first one is 300 atoms of A. It means we have 300 atoms of A and 200 molecules of B2. Okay students, अगर 300 मॉलिक्यूल A के हैं तो 300 ही B2 के चाहिए होंगे. Why? Because one molecule reacts with one atom reacts with one molecule, तो 300 भी 300 से ही react करेंगे. And here 300 and 200, it means 200 molecule of B2 is the limiting reagent. That is limiting reagent. And we will see the second one, 2 mole of A. 2 mole अगर A के हैं तो 3 mole B2, 3 mole B2. Here 2 mole reacts with 2 mole, 3 mole react with 3 mole. It means this is the limiting reagent. Okay students, 100 atom अगर हैं A के और 100 molecule हैं B2 के, it means here limiting reagent is not present. Both are present in sufficient amount and react with each other because both are in same amount present and required. Now the next one is 5 mole of A. 5 mole of A means 5 mole of A atoms are present and 2.5 mole B2. It means B2 कम है, B2 is lesser because 5 mole react करेगा 5 के साथ. Hence B2 is the limiting reagent. In the last one you can see 2.4 mole of A and 5 mole of B2. It means this is the limiting reagent. जो भी कम अमाउंट में है अपने रिक्वायरमेंट से उसे ही हम लिमिटिंग रिएजेंट बोलेंगे. यू विल डू सम मोर न्यूमेरिकल्स फ्रॉम योर NCERT book of same concept. Okay,